All right, welcome to today's video, our last video of the unit. Today we're going to be looking at quadrilaterals, all of the quadrilaterals, and identifying the quadrilaterals based on their properties. First, we're going to just kind of look at this flow chart. Remember that everything we've talked about so far is a quadrilateral. So this just kind of shows you how everything's related to each other. So quadrilateral is at the top, and then it flows down to a parallelogram. Then parallelogram divides up into rectangles and rhombuses, which come together to make a square. So remember that every single one of these shapes has the properties of whatever shapes come before it. So rectangles, rhombuses, and squares all have parallelogram properties, and then a square has rectangle and rhombus properties. We've got trapezoids and isosceles trapezoids. Isosceles trapezoid would have trapezoid properties, and a kite's kind of on its own out here. It really has no unique, doesn't share any properties with any of the other quadrilaterals besides just having 4 sides and an interior angle sum of 360, like all of the quadrilaterals. So, by now we should have hopefully created a list of properties. We can kind of use that to figure out what some of these quadrilaterals are based on their properties. So we're given that quadrilateral ABCD has both pairs of opposite sides congruent. What types of quadrilaterals meet this condition? So what we want to do is we want to look at our properties and say, which quadrilaterals have the properties where both pairs of opposite sides are congruent. And if we remember, that's a parallelogram property. So we definitely know that parallelogram is going to work for this. We can kind of think about trapezoids. An isosceles trapezoid would have one pair of opposite sides congruent, but not both pairs. And then a kite has consecutive pairs of sides that are congruent, so that's not going to work either. Now the thing with this, if we say parallelogram, we need to include all of the shapes that come underneath parallelogram. So rhombus, rectangle, and square. Since the last 3 are all considered parallelograms, therefore they would meet the property that both pairs of opposite sides are congruent. Example number 2, looking at the diagram, what is the most specific name for this quadrilateral? Now, one of the things we want to really make sure that we stay away from is looking at the diagram and saying, well, this looks like a square. And I agree that it does look like a square, but we need to go based on given information. What do we know? What's given to us? And what we're given is that AB, BC, CD, and AD are all congruent to each other. So there's 4 sides in the quadrilateral, and all 4 sides are congruent. We don't know anything about angles of this quadrilateral, so I can't make assumptions based on the way that something looks. So based on this quadrilateral having all 4 sides congruent, the most specific name for this is going to be rhombus. Again, we can't assume things based on the way things look. Again, if I knew angle measures, for example, if I was given that angle D was a right angle, well, now I can conclude other things about this being a square possibly. But we can only go with the properties that were given in the diagram. Our final example has us identify the quadrilateral again, and again we're going to have to go through and figure out what properties are given to us and how we're going to figure this out. We know that angles F and G are both 102 degrees, and angle H is given us to 78 degrees. Now realize these angles don't look like they're 102 and 78 degrees. However, we can't assume things based on the diagram. We have to go based on our given. And what we need to know is what this 4th angle is going to be. So we know that all 4 angles, add up to 360. So if I call this X, I'll say X plus 78 plus 102 plus 102 equals 360. So X plus, add this up and I'll get 282 equals 360. Subtract 282 from both sides. And X is going to equal 78. So what I have is a quadrilateral where the top 2 angles are congruent and the bottom 2 angles are congruent. And so these would be considered our base angles, and this would be an example of what an isosceles trapezoid would be. So based on our properties from trapezoids and isosceles trapezoids, if I have 2 pairs of base angles that are congruent to each other, then we're going to have an isosceles trapezoid. And again, this is where the properties that we did are going to verify this. So yes, it's an isosceles trapezoid. because we have two pairs of congruent base angles. That's it for this. It's a pretty short one. Again, make sure you know your properties. If you haven't already, create a list of all your properties, and so you can know the difference between one quadrilateral to the next one. If you have any questions, write them down and ask them next time we see you. Have a good night.